Welcome everyone to our webinar. And I hope you are staying at home, enjoying your life and enjoying this presentation. So today our webinar is about extracting COVID-19 signs and symptoms from clinical notes. My name is Yaoyun Zhang. I'm the Director of IOP Technology at Melax. So currently we only have currently this study is only in stage 1. We have some preliminary work that we would like to share with our audience and our community so that to get more feedbacks and let our community be aware that we have this resource and we will make it in public for free. Currently, actually, we have a lot of public COVID-19 datasets. But I actually listed several major types here, if not exhaustive. So I think the major ones are the biomedical literature and imaging data. For clinical data, we also have some structured lab tests and values making public for some regression analysis. And also, I see some researchers also collected the social media data, like the news about COVID-19 and the tweets related to COVID-19. And also, the only one currently I found in public related to clinical notes or with kind of like a similar content as clinical notes is a medical dialogue between patients and the doctors online. So I guess many of you probably already know this one, the COVID-19 Open Research Dataset challenge. It is organized by several major shareholders in this community, including several institutions, companies in NIH and the White House. And it is a very large set of biomedical articles. So in total, it has 59,000 scholar articles. And this is a call for all the entire community to participate in this challenge and extract the data, extract the informative information to help progress in the COVID-19 research. And another example I like to show is the medical dialogue because it's somewhat similar to the clinical text. So this is a question crowd from an online QA platform. And this is the description. The patient has some symptoms and the patient is worried that it probably is a symptom of COVID-19. And here is the detailed description. Actually, since we cannot find any public data to test our model as an external test, we used this dialogue data as one external evaluation. So why we want to extract the COVID-19 signs and symptoms from patient data? It has actually many potential applications. For example, for population-based surveillance and for a quickly and automatic or semi-automatic diagnosis and prevention of COVID-19, as well as clinical data-based analysis to do some prediction models based on patients' demographic information and some other related informations. So that's what motivates us to start this work to build an information model of signs and symptoms, and also to contribute one pipeline specific to COVID-19. And so we actually followed the information model of the problem concept in CLAMP. So basically, the sign symptoms currently we consider it similar as the definition of problem in concept, and our current information model mainly contains 6 major attributes of sign and symptoms. One is the negation, whether the patient has that symptom or not, or it is kind of like conditional. If something happens, then so it is not actual symptom of the patient, and also the body location of the specific symptom, like lower GI bleeding, and the severity, whether it is acute or it is a moderate symptom, and also temporal information. So temporal information is also a very important information related to the symptoms, especially the onset time. So we also include this attribute inside. And of course, whether so what is the development of the symptom, whether it is increasing or it's worsening. And so we need some authoritative resources to tell us what are the specific signs and symptoms of COVID-19. And there are actually multiple resources currently are sharing their suggestions of signs and symptoms. So I listed several ones. If you have additional resources, please let me know. Currently, our sign and symptom scope are mainly based on these several resources. The first is the WHO case report form. So this is an example of the case report form. This is a structured table of signs and symptoms on admission, and it lists several types of signs and symptoms here. And in addition to this case record form, we also search and collected more signs and symptoms from other resources like the National COVID Cohort Collaborative. They have some phenotyping codes. And also before the CLAMP COVID-19 model, there's another existing LP tool called MedTagger. It is from the Mayo Clinic. They actually built a short list of sign symptoms with synonyms and use rule-based methodology to build a symptom recognition model. You could also search and try it. And also there are other research websites that secure COVID research. They have shared a controlled vocabulary, including signs, symptoms, and others like medication and lab tests. And also Immerse, it's a search engine for clinical notes. And they shared a comprehensive list of synonyms of some important COVID-19 based clinical concepts. And also there are potential misspellings. So thank you. I would like to take this opportunity to thank all of those resources and those sharing. And actually, our model is so this serves as the backbone of our model. So this is an overview of the workflow of how the COVID-19 sign symptom model is built. So because CLAMP, the motivation of CLAMP is built for conveniently customize the LP models to specific use case. And for this specific use case, actually, it is built based on the basic core model of LP, which recognize the problem, medication, and lab test, as well as their attributes. At this stage, we only focus on the signs and symptoms. And the first step is to recognize the signs and symptoms. and also their attributes from based on CLAMP's core model. And we actually used a hybrid method. We used the deep learning-based methods to recognize the sign symptoms, and also joint learning-based method to recognize the attributes. And in addition, we also used the vocabularies from Humorless and also from our collected controlled vocabularies, and as well as regular expressions and rule sets to recognize different attributes. So our overall goal is to get the optimized performance. And after we recognize the signs, symptoms, and their attributes, they are encoded automatically to Humorless QEs. And after this pipeline, we add extra 2 steps. So we make a filter upon the output of CLAMP, and we filter out only the signs symptoms of COVID-19 using the QEs and vocabularies rebuilt. And if the sign symptoms are related to COVID-19, we will keep them as well as their attributes and remove all the other clinical problems. So this is the LP pipeline we used. So if you actually, if you have CLAMP at hand, you could also try to build some customized pipeline. And as can be seen, we use the for named entity recognizer. How many are here? 4 named entity recognizers using both deep learning-based core concept recognition and data format matcher to recognize temporal information and dictionary lookup to further improve the recall, and also the negation regular expressions to recognize the assertions of negations, and all the rest. Yeah, I will not go through each and every step of this pipeline, but just want to let you know that it's actually the pipeline is very flexible. You could add whatever needed for you for your specific task into the pipeline, and it will be implemented sequentially, especially when you have multiple types of clinical concepts or relations that need to be recognized. And it's very flexible for you to mix dictionary rules, regular expressions, machine learning, and all of those together. Okay, so how we evaluate this pipeline? For the external evaluation, since we don't have COVID-19 data at our hand, so we use the 50 discharge summaries from MX3 as our preliminary evaluation and 1,000 sign symptoms to check their QE correction. And for external evaluation, currently we use the 50 medical dialogues collected by UCSD. They share this resource in GitHub. Yeah, you could search and try to find it. This is also very convenient. So actually, this whole pipeline are relying on many shared resources. And this is one example of our current results. So, for example, SOB is short of breathlessness, and this is the negation modifier. And the temporal expression, it is connected to the cough symptom. And if you put your mouse upon this, excuse me. If you, let me mute myself for a while. I'm back. Okay, if you put your mouse on the semantic type, it will automatically show the standard QEs. this concept inside humorless. So here's another example. It has several signs symptoms labeled and also with a condition attribute. That means those conditions are not actually happening to the patient. And also, this is a demonstration of the standardized QEs of this high fever concept. Both the QE in humorless and also the preferred term of this concept are listed here. So for our internal evaluation, we use the Melax 3. We randomly choose a set of discharge summaries that potentially have the signs and symptoms. And this table lists the performance of each somatic type. So for sign and symptom, we evaluated the entity recognition performance. And for the rest attributes, we evaluated their relation recognition performance, because all the other attributes are actually surrounding the signs and symptoms as a core concept. As can be seen, I think this preliminary model performs well on Melax 3. But some of them, such as condition, it has a quite low performance, especially the precision. So we will provide a detailed error analysis later. And for the humorless encoding, we also did an evaluation, and accuracy is 91%. I think this is comparable to the current state-of-the-art performance. And for the medical dialogue, actually the performance drops for several points. For example, the sign symptoms, it has a lower record and leading to a lower F measure of 87.3%. This is still actually it's a promising result, but it definitely drops from the Melax 3. And for the rest attributes, 2 of them actually have a quite low performance. One is the temporal and another is the condition. So similar with the Melax 3, the conditional attributes also has a very low performance. Why would that happen? Let's look into some analysis with examples. So several major types of errors. The first one is missing modifier. For example, the right screenshots, it did not recognize the negation modifier here. So we probably need to optimize our negation model using some machine learning based methods. So currently we are using the NetJax. So I think this is a very, it's also a very popular toolkit for negation or assertion recognition, but it still need to be optimized on this dataset. And another is wrong boundary of the named entities. Currently, we are doing an exact match-based evaluation. Some of the concepts, actually, for example, this one, cough, the entire scope will be cough productive of yellow sputum. So this is a more specific concept. In fact, both cough and this longer, more the concept with a finer granularity, actually both of them are included in our current vocabulary. However, if our target is mainly the priority is for the specific concept, then it is considered a wrong recognition. So another problem is the word ambiguation. For example, this conjunction, it is actually not a sign or symptom, but it is mistakenly recognized. And another problem is the document structure. For example, this one, actually the reason why the condition has a poor performance is mainly because of this. So it's actually in the discharge instruction section. So it will have several statements listed as a list, and it all under this if you have any of the following section. And currently, our model can only recognize the first link between the condition and the sign and symptom, and the rest concepts in the list that missed the connection to the condition. So we need to recognize the list structure of the nodes first to recover those relations. And another major type of error, actually, this is some dialogue example we've reviewed together previously. So I use this here as example for the potential errors. We have relatively poor performance in the temporal expression and relation recognition, and also condition. So let's see. In this text, actually, it has several. Okay, here. It has several expressions of temporal events, right? Get a cough for last few days and heavy during nighttime and other symptoms. And it has been 4 to 5 days. Actually, it has some cross sentence temporal expressions that need to be linked back to those signs and symptoms. But now our model cannot handle this yet. So that's why the temporal information has a low performance. Okay. And here is a list of errors for the QEs. For example, the granularity difference, the any favor, it should be matched to favor, but it matched to a child concept. And also the SOB, it is actually a ambiguous term. It can be mapped to crying or shortness of breath, but actually it should be corrected dependent on the concept. And also this one, weight loss and chest pain. So because they are connected, and the model failed to recognize to match the chest pain, which we are mainly interested in, and mapped the weight loss. And here's another one. The significant blood loss, it is matched to significant tissue loss. And another, the last one is violent coughing. Somehow it only kept the QE of violent, but didn't keep the concept of coughing. But this can be easily recovered because we actually will recognize violent as a severity, and the coughing is the sign and the symptoms. So both of them will have QEs assigned. So basically, based on our error analysis, we need to collect more patterns and try to make our model more tailored to the data.
Maggie 你好。
And also,
对，我今天教，还没有教，今天教。
sorry for this interruption. So, yeah. And also, we need to get familiar with the specific structure of the data we are handling so that we could easily remove some errors that actually influence the performance a lot. Okay. So as a discussion, based on our current evaluation, the claimed COVID-19 pipeline for the clinical data actually have a quite promising performance. And we could continue to customize the pipeline to make it tailored to the medical dialogue data and to handle several major types of the errors. One big limitation of our current work is we have a very limited sample size of evaluation given this short time. But anyway, we want to present it to the community and get feedback for potential improvement. And we also want to share this with our community. We probably will put this version online and keep improving it in the near future. And for the pipeline customization, we definitely need to do further customization on specific sites. So currently, I just sent yesterday. I sent this pipeline to a faculty medicine in Johns Hopkins, and they actually have a set of clinical notes. He is helping me to test it and to see if we need to make additional adjustment. And also for specific genres like medical dialogue or tweets data, we need to do further customizations. And in addition, we want to expand our current information scope to comorbidity and the lab test, medication, all the other important clinical information inside the patient data. All right, so that's it.